In this lecture, we are going to construct a confidence interval for the unknown population mean mu. To be able to do that, we will make use of the sampling distribution of the sample mean x bar. Now remember that the mean of the sampling distribution of x bar is equal to the population mean. The variance of the sampling distribution is equal to the population variance divided by n, the sample size, and the standard error, which is just the standard deviation of the sampling distribution, is sigma divided by the square root of n. If the population follows a non-normal distribution, then the sampling distribution of x bar follows an approximate normal distribution for sufficiently large sizes of n. If x follows a normal distribution, then x bar, the sampling distribution of the sample mean, also follows the normal distribution for any value of the sample size. From this we can see that if we standardize x bar by subtracting mu and dividing by the standard error sigma over square root n, then this standardized statistic will also follow the standard normal distribution. We also know that the probability that z, random variable z, that follows the standard normal distribution, the probability that z lies between minus z alpha over 2 and positive z alpha over 2 is 1 minus alpha. For example, if we take alpha 0.05, then the probability that z lies between minus z 0.05 over 2 and positive z 0.05 over 2 is 1 minus alpha, 1 minus 0.05. In other words, the probability that z lies between minus z 0.025 and positive z 0.025 is 0.95. And from a previous lecture, we know that z 0.025 is equal to 1.96. So that means that if this is my standard normal distribution, then the area to the left of minus 1.96 and the area to the right of positive 1.96 are both 0.025. In other words, the area in between will be 0.95 because the total area has to add up to 1. Okay, now we can substitute this z value with the standardized statistic over here. And we can say that the probability that this statistic lies between minus z alpha over 2 and positive z alpha over 2 is 1 minus alpha. So with the necessary algebraic manipulations, we get that the probability that mu lies between x bar minus z times the standard deviation and x bar plus z times the standard deviation is 1 minus alpha. So this now gives us a confidence interval for the population mean when the population standard deviation sigma is known. 1 minus alpha is called the confidence level, and x bar minus z times the standard error is the lower confidence limit, and x bar plus z times the standard error is the upper confidence limit. When we set up confidence intervals or confidence estimates, we usually make use of the 90%, the 95%, or the 99% confidence intervals. For example, to set up a 90% confidence interval, 1 minus alpha will be 0.9, so alpha will be 0.1, alpha over 2, 0.05, and z 0.05 you will find in your normal tables as 1.645. The same if we want to set up a 95% confidence interval, then 1 minus alpha is 0.95. Alpha will be 0.05, so alpha over 2 is 0.025, and Z 0.025 from the normal tables is 1.96. Okay, and we will make use of these Z values when we set up confidence intervals and do hypothesis testing at a later stage.